general relativity, step by step. I've established these three identities here for the Riemann-Christoffel tensor, and now I'm going to talk about another one, or another set of identities at least, called the Bianchi identities. Bianchi identities. And I discover that I've been saying it wrong all my life. All my life I've called them the Bianchi identities, but it's not, it's Bianchi. Okay, so what is this? Well, rather than just an algebraic relationship, this has got differentials in it. So what we're going to do is start with the Riemann-Christoffel tensor, mu, nu, and I'm going to have covariant differentiation with respect to sigma. And I'm going to add our alpha, beta. Alpha and beta stay the same, but these three things here, these three indices here, I'm going to permute. So we've got mu, nu, semi-sigma, so I've got something, something, semicolon, something, and I'm just going to move everything to the right. So mu, nu, sigma, mu, nu, sigma, plus, and then the final one, r, alpha and beta stay the same, blah, blah, semicolon, blah, mu, nu, sigma, mu, nu, sigma. Now it's mu, nu, sigma. And when you add these three guys, that equals 0. And again, if we remember the definition of the Riemann-Christoffel curvature tensor, it's quite a beast. There's quite a lot going on. So what I'm going to do is I'm going to consider an elevator frame. That's me sitting in an elevator. Local inertial frame in which my metric tensor is nice and constant. So that means that my Christoffel symbols are all 0, and that means that we've got a nice simple definition for the Riemann-Christoffel curvature tensor, which I should have here. Oh, here it is. Look, I've still got it. There it is. There it is. So I'm going to use this. There we go. So that's it there. Alpha, beta, mu, nu equals this. And I am going to covariantly differentiate with respect to sigma. Actually, I'm not. What I'm going to do is just take an ordinary derivative with respect to sigma because I'm in an inertial frame, so it doesn't matter. So I'm just going to put brackets around that guy there, comma, sigma. Pinch in just a little bit. Quite a lot of rubbish on my screen here. Let's just get rid of these. There we go. Plus r, alpha, beta, and then we're going to move everything to the right. So it's sigma, mu, comma, nu, and I may as well do the other one while I'm thinking about it. Alpha, beta, nu comes up there, then sigma, then comma, mu. Just check, sigma, mu, 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 mu. You see, mu moves one place to the right. Nu moves one place to the right and starts again. That moves there. And then one step to the right, that's right. Equals. See if I can do it all nicely. G, blah, blah, comma, blah, blah, minus G, blah, blah, comma, blah, blah, minus G, blah, blah, comma, blah, blah, plus G, blah, blah, comma, blah, blah. Comma, nu. And this one is comma, mu. So of course I'm going to use the fact that differentiation commutes past addition to work out these guys here. I'll pinch in a little bit so I can do it. Okay, so alpha and beta don't change. So I'll just write it in everywhere I see it. Alpha and beta is there. Is it faster to do all the alphas first? Yeah, let's do all the alphas first. Alpha, alpha. Copying from here, and here alpha is in the final position. Now I better do the betas. I've done that one. Betas, oops, betas here. Yeah, because beta doesn't move. Alpha and beta don't move. Beta's in the final position here and here. And it's in the initial position here and here. Okay, now things get a bit harder because I've got alpha, which is staying constant. Now mu turns into sigma. So every time I see a mu here, I've got to write a sigma. Mu goes to sigma. Because it's there, that's right. Mu goes to sigma. mu goes to sigma, a little bit tight in space here. And the other index must be where the nu was, it is now a mu. So there's only one space left. There's only one slot there for my mu to go, which is here. Mu goes there and there. That's right, because the nu here has turned to a mu here. Nu has turned into a mu. Okay, the sigma turns into a nu. 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 And the sigma turns into a nu. What's left? What have I not done yet? I've done that one. Oops. I'm quite sure what happened there. The sigma turns into a mu. Now the mu turns... Sigma turns to nu. Now mu turns to sigma. Mu turns to sigma. Mu turns to sigma. Mu turns to sigma. There it is. Right. So I've got all these things here, and now, well, let's have a look at all this. What have I got? What a mess. Well, it isn't as bad as it looks, because this differentiation here is ordinary differentiation. That's not a semicolon. That's just a comma. Comma goes to semicolon rule is incredibly powerful. I've got enough space to do it here. Yeah, I've got these three terms here. Maybe I'll put it here. G. So I'm copying this term down. Nu alpha, comma, mu beta sigma minus, because I've got that beta and I'm differentiating with respect to x sigma, minus G nu beta, comma, mu alpha sigma minus this term, G mu alpha, comma, nu beta sigma plus G beta mu, comma, nu alpha sigma plus this term here, G, can pinch in a little bit, this term here I'm doing, mu alpha, comma, sigma beta nu minus G mu beta, comma, sigma alpha nu minus G, this term, sigma alpha, comma, mu beta nu plus the final term, G beta sigma, comma, mu alpha nu. At this point, I just want to make the observation, this is a rather mechanical process, but I just want to be clear that I'm not thinking in terms of, oh, it's this component and that component. It's just formal manipulation of symbols at this point. Plus, now I'll do the last one, mu, sigma alpha, and then we'll start looking for things to cancel, comma, nu beta, and it's with respect to mu here, minus G sigma beta, comma, nu alpha mu, minus G, this term, nu alpha. Oh, what is that? What is that? The nu went into a mu. I've missed a term out here, haven't I? Of course. Let me just have a think about that. Yeah, look, mu goes to sigma, mu goes to sigma, mu, we don't know, but mu goes to sigma, so this one's going to have to go to sigma as well. Okay, so what does it turn into? I'm doing this term here, comma, sigma beta mu, plus the final term, G beta nu, comma, sigma alpha, and then a mu term there. Whew, quite a lot of stuff there. I'm going to stop there, and in the next screencast I will show you how to cancel all these things out. Okay, stop there, stop.